Hello students, welcome. In this problem, 5 identical charges capital Q are placed equidistant on semicircular shape. So capital Q that is placed in equal distance in semicircular shape. In center we have a small q. Okay. So what they are asking is that what is the electrostatic force experienced by small q. So we know that force it is vector quantity and that follow principle of superposition. Now what will happen, there will be a force between the charges. So now the total force on capital Q will be, the first force will be due to this capital Q on small q. So this is both are positive charges, so it is going to be repulsive force. So it is repulsive force. Okay, so I can draw like this, due to this capital Q, and the force here is in this direction. Okay, so I'll put it, so this is the direction, repulsive force. What is the magnitude? The magnitude is, I can write here. So let us take it as this is first charge. Okay. So due to first charge, I can put the forces F1 here. Okay. So that is something like K, product of their charges, and distance. Distance is radius. Similarly, I have another charge. So here, due to this charge, you can see clearly, due to this charge, the force here will be repulsive, so along the line. So this force will be like this, right? So it's repulsive. So this is force F. And what is the magnitude of this force? So this force magnitude also as same as that here, right? Because the distance here again, radius is r, and charge is also same. So this is another force, same force. Like here also we will take F2, but we know that both are equal magnitude, so I can also write that as F as a force. So this here it is F as a force. So force is F, and here force is F. So another is, due to this charge, the force will be here, it is along this direction, and this is another force, and here due to this charge, and the force will be in this radially outward, so in this direction. Due to this charge, the force will be in this direction, right? So you see that, so there are 1 2 3 4 5 6 point charges. How many forces are there? There are 5 forces are there, all are repulsive forces. Now I want to find out what is net force. We know that there are n ways to do this problems, but the simplest way is that, and shortest way is that, by considering equal forces, two equal forces, let's say this force and this force, both are equal and opposite, right? So they cancel each other. And now what I have is that this two forces, so they cancel each other. Now what about this two forces? So this force and this force, we know that this is equal distance, this angle must be 45 degree. If this is 45 degree, this is also 45 degree, and this is 45 degree, this is also 45 degree. Now what is the force, what is the angle between these two forces? So overall 90 degree. Already one force is here, right? So I'll take this two forces. So one force is like this, another force is like this. Okay, so angle between them is 90 degree, and now I can add vector addition. If I add vector addition, the resultant will be like this, right? So this is F, this is also F, this is F, this is also F. What about this force? We know the two forces acting 90 degree means the resultant will be root 2 times of one of the force, and angle also exactly 45 degree. So the resultant force here will be F root 2. Okay, and exactly that is along parallel to the last force. So here you see that I have F and F. What is the angle between them? 0 degree. Then the net force will be, the net force is, so root 2 F plus F, right? So the resultant of this force acted, I got F root 2, and already one more force is there, so both is getting adding up. What about other two forces? These two forces are cancel each other. Now we know that what is a force here? The force is in vector form, I can write. So if I write it as vector form, so here I can take a capital F outside. So this is root 2 plus 1. And what direction is this? So this is I cap, right? And this is j cap. So it's nothing to do with j cap, only I cap. So I can write it as K capital Q by how much? R square, Q square, capital Q and small q, R square. So root 2 plus 1 I cap. So this is the resultant force on charge small q, that is at center.